Welcome to today's tutorial. Today we are solving a physics problem on motion. A bus driver is moving at a velocity of 100 km per hour. Suddenly sees as goat crossing the highway 49 meters ahead. He hits hard on his brake to get a maximum retardation of 8 meters per second square. How far will he go before stopping? And can he avoid eating the goat? Before we proceed to solving this problem, at my right hand side here are some useful formula that you have to take into consideration before solving it. And the first one, or the first set up here, are just the formula that you can apply whenever you are dealing with acceleration. That is, when a body is accelerating, you consider this equation that has positive sign, and whenever a body is undergoing a retardation or deceleration, whenever a body is decelerating, you take into consideration the below formulas, that is those ones that are having negative signs between them. Also below here is a very useful conversion formula. 1 hour is equivalent to 3600 seconds and 1 kilometer is equivalent to 1000 meters. Now let's proceed to solving the problem. Before we solve the problem, we need to write out the parameters given in the equation. A bus driver is moving at a velocity of 100 km. Here the bus driver is moving, is still on motion. So we ask ourselves, would this be initial velocity or final velocity? It will be actually initial velocity because the driver or the bus driver is still moving. It is still on motion. Therefore, u, which is a symbol for initial velocity, will be 100 km per hour. But here we need to carry out the conversion because we are actually dealing with SI units. We need to convert kilometer per hour to meter per second. And how do you do that? Whenever you are converting a value from kilometer per hour to meter per second, what you need to do is multiply that value in kilometer per hour, say 100 as given here, by 1000 and divide by 3600. And when you carry out this by your calculator, you are going to arrive at 27.78 meter per second. But the quickest way I usually use whenever I want to convert from kilometer per hour to meter per second is just to multiply that value in kilometer per hour. Here we are having 100. I will multiply it by 0.2778. So whenever you are given any value in kilometer per hour and you want to convert to meter per second, simply multiply that value by 0.2778. And if you carry out this, you're also going to arrive at 27.78 meter per second. Alright, let's proceed. Now, suddenly sees as goat crossing the highway 49 meters ahead. He hits hard on his brake to get a maximum retardation of 8 meters per second square. Here we are dealing with retardation, and we denote that with A. Retardation is 8 meters per second square, and you can also write it in this form, 8 meters per second square. Also, he hits hard on his, yes, we have read that. How far will he go before stopping? This statement is very important because it actually carries two important variables that you need to take into consideration. The first one is how far. How far is actually the distance. How far. Whenever you see how far, you are asked to find the distance. Whenever you see how long, you are asked to find the time. How far will he go before stopping? Here, before stopping is actually telling you that the vehicle or the bus will eventually stop, and when it is stopping, the final velocity will be equal to 0. Can you see that now? Now, what next? Let me go do away with this. What next is to choose the most suitable formula here and apply. You have to take note here that we are dealing with retardation. Therefore, we are considering the formula written below here. And among the three formula here, which one are we going to choose? You have to come back to the parameters given. If you look closely here, you see that time is not given and we are not asked to look for time. Therefore, we can do away with all the expression that has t time here. This one has gone and this one has gone. So we are left with v square is equal to u square minus 2ax. V square is equal to u square minus 2ax. Now we need to substitute. V is equal to 0, right? And u is 27.78. We have determined that. And don't forget to square. 27.78 square minus 2 times a, our acceleration is 8, times x. X is the unknown value, that is the how far, the distance. Now 0 will be equal to, if you input this into your calculator, you're going to arrive at 771.73, and if you input this, you are going to arrive at 16x. What we need to do is to rewrite the equation. So it will be, if you take this to the other side, the negative sign will change to positive sign. So we have 16x is equal to 771.73. And what we need to do here is to divide through by 16. So we are left with 771.73 all over 16. If you input this in your calculator, you are going to arrive at 48.23. And since we are dealing with distance, the unit is meter. So this is the distance. This is the distance that the moving vehicle or the moving box we actually cover before stopping, while applying a uniform retardation of 8 meters per second. Now, on to the last question here. Can he avoid eating the goat? You have to look at the question again. A bus driver is moving at a velocity of 100 km per hour, suddenly sees as goat crossing the highway 49 meters ahead. So the goat is still 49 meters ahead. Say this is the box. And this is our goat here. Don't mind my diagram. The distance between the box and the goat is 49 meters. And if the bus driver apply a maximum retardation of 8 meters per second, it will cover a distance of 48.23 meters. Therefore, it will just avoid eating the goat because we can't approximate this. And since the goat is still 49 meters ahead, if you subtract this from this, you are going to get 1.23 meters. This is actually a long distance. Therefore, the vehicle, the bus driver, will just avoid eating the goat.